Welcome back to Djji Tutorials. Hope you're ready to dive into this session as we cover angles in standard position as it relates to the definition of trig functions. An angle in standard position has its vertex at the origin of a coordinate plane and its initial side along the positive x-axis. This position is fundamental for defining trigonometric functions, as it allows us to associate an angle with a point on the unit circle or a point on the terminal side of the angle. Here's a more detailed explanation. Defining the angle and vertex. The point where the two sides of the angle meet is the vertex, and in standard position, this vertex is located at the origin, 0, 0, on the coordinate plane. Initial side. The first side of the angle, the ray starting from the vertex, is the initial side. In standard position, this initial side always lies along the positive x-axis. Terminal side. The second side of the angle, which rotates from the initial side, is the terminal side. The position of the terminal side determines the angle's measure. Defining trigonometric functions. Using the unit circle. We can define the trigonometric functions like sine, cosine, tangent, and others, by using a unit circle, which is a circle with a radius of 1, centered at the origin. The terminal side of an angle in standard position intersects the unit circle at a point, x, y. Relating to the point x, y, the x-coordinate of the point x, y is the cosine of the angle, or cos theta. The y-coordinate of the point x, y is the sine of the angle, or sin theta. The tangent of the angle tan theta is the ratio of the y-coordinate to the x-coordinate y over x, extension to other points. We can extend these definitions to any point on the terminal side of the angle, not just on the unit circle. The trigonometric functions are defined as ratios of the x, y, and r coordinates, where r is the distance from the origin to the point x, y. Why is the standard position important? Well, let's break it down. First, consistency. Standard position provides a consistent way to define angles and their trigonometric functions, regardless of the angle's actual location. Next, visualization. It allows for easy visualization of angles and their relationship to the coordinate plane. And finally, calculations. It makes it easier to calculate trigonometric function values by relating them to the coordinates of a point on the unit circle or terminal side. Coterminal angles are angles that share the same terminal side when in standard position. This means their initial side starts on the positive x-axis, and their terminal side ends at a specific point on the circle, coinciding with each other. The principal angle is the smallest positive angle in a set of coterminal angles, falling between 0 and 360 degrees. Meanwhile, the reference angle is the acute angle, less than 90 degrees, formed between the terminal side of an angle and the x-axis. So what exactly are coterminal angles? Coterminal angles have the same terminal side when measured in standard position, with the initial side on the positive x-axis. To find coterminal angles, you can add or subtract multiples of 360 degrees or 2 pi radians from the original angle. For instance, 30 degrees, 390 degrees, and negative 330 degrees are all coterminal. The principal angle is the smallest positive coterminal angle, always between 0 degrees and 360 degrees or 0 and 2 pi radians. To find the principal angle, you can add or subtract multiples of 360 degrees until the result falls within the range of 0 to 360 degrees. For example, if an angle is negative 100 degrees, the principal angle would be 260 degrees because negative 100 plus 360 equals 260. The reference angle is the acute angle, which is less than 90 degrees formed between the terminal side of the angle and the x-axis. To find it, if the terminal side is in the first quadrant, the reference angle is the angle itself. If the terminal side is in the second quadrant, the reference angle is 180 degrees minus the angle, or pi minus the angle in radians. If the terminal side is in the third quadrant, the reference angle is the angle minus 180 degrees, or the angle minus pi in radians. And if the terminal side is in the fourth quadrant, the reference angle is 360 degrees minus the angle, or 2 pi minus the angle in radians. For instance, if an angle is 225 degrees, the reference angle is 45 degrees because 225 minus 180 equals 45. The three primary trigonometric ratios, sine, cosine, and tangent, can be defined in terms of x, y, and r, where r is the hypotenuse. Sine or sin is the ratio of the y-coordinate, which is the opposite side to the hypotenuse, r. So, sin theta equals y over r cosine or cos is the ratio of the x-coordinate, which is the adjacent side to the hypotenuse, r. So, cos theta equals x over r tangent or tan is the ratio of the y-coordinate, which is the opposite side, to the x-coordinate, which is the adjacent side. So tan theta equals y over x. The three reciprocal trigonometric ratios are cosecant, secant, and cotangent. They are defined as the reciprocals of the sine, cosine, and tangent functions, respectively. Cosecant, or CSC, is the reciprocal of the sine function. It's defined as the ratio of the hypotenuse to the opposite side in a right triangle, or 1 over sine of theta. Secant, or CC, is the reciprocal of the cosine function. It's defined as the ratio of the hypotenuse to the adjacent side in a right triangle, or 1 over cosine of theta. Cotangent, or cot, is the reciprocal of the tangent function. It's defined as the ratio of the adjacent side to the opposite side in a right triangle, or 1 over tangent of theta. In summary, cosecant of theta equals 1 over sine of theta, which is the hypotenuse over the opposite side. Secant of theta equals 1 over cosine of theta, which is the hypotenuse over the adjacent side. Cotangent of theta equals 1 over tangent of theta, which is the adjacent side over the opposite side. In trigonometry, the signs of trigonometric ratios, sine, cosine, and tangent, are determined by the quadrant in which the angle lies. Quadrant 1, from 0 to 90 degrees, has all ratios positive. Quadrant 2, from 90 to 180 degrees, has only sine positive. Quadrant 3, from 180 to 270 degrees, has only tangent positive. Quadrant 4, from 270 to 360 degrees, has only cosine positive. Here's a more detailed breakdown. In quadrant 1 from 0 to 90 degrees, all trigonometric ratios, sine, cosine, and tangent, are positive. In quadrant 2 from 90 to 180 degrees, only sine is positive, while cosine and tangent are negative. In quadrant 3 from 180 to 270 degrees, only tangent is positive, with sine and cosine being negative. Finally, in quadrant 4, from 270 to 360 degrees, only cosine is positive and sine and tangent are negative. Memory aid. The CAST rule can help you remember which trigonometric ratios are positive in each quadrant. C stands for cosine, A for all, S for sine, and T for tangent. So cosine is positive in quadrant 4, all are positive in quadrant 1, sine is positive in quadrant 2, and tangent is positive in quadrant 3. Alternatively, you can use the acronym ASTC, which stands for All Students Take Calculus, to remember which trigonometric ratios are positive in each quadrant, starting with quadrant 1. Explanation. These rules are based on the signs of the x and y coordinates of points on the unit circle, which are related to the cosine and sine values respectively. The tangent is the ratio of sine to cosine, so its sign depends on the signs of both. We hope you found this lesson useful. See you in our next session.